8.2D, which is comparing and ordering real numbers. So we're going to focus on applying it to word problems and how they might word these types of problems on an assessment. So here again, key thing we want to focus on is understanding the terms and vocabulary associated with least to greatest and greatest to least. So this table here shows the words associated or that we might see in a problem. And again, we need to remember that if we're talking about least to greatest here, again, you might see the words ascending or increasing order. Okay, and if we're talking about greatest to least over here, you might see it described as descending or decreasing. So keep those in mind when we're solving these example problems together. Okay, and just a quick review from yesterday. Again, here's a visual. Again, least to greatest means ascending, meaning you're working or arranging your numbers from smallest to largest. And again, this visual just shows the little girl here climbing up the stairs, again, gradually getting bigger. Again, or our term is here increasing, whereas on the opposite side we have descending, okay, which is representing greatest to least, where the little boy here is starting at the top of the stairs and going down, which describes decreasing. Okay, so just again, make sure we're understanding the vocabulary and the words associated with these least to greatest and greatest to least so that we can answer the questions correctly. All right, so let's look at example number 1. All right, number 1 says, 4 people have found the distance in kilometers across a canyon. Put the distance in descending order. Okay, so one thing I do want to talk about, guys, is on an assessment, if you're given a table such as this or any type of drawing or graph, please make sure you're reading what the table is actually about. Okay, it helps with understanding the problem. Okay, and it's just not just numbers. So here it wants us to put it in descending order, and again, we just talked about that. So that means that descending, we're starting big to small, which is another way to say greatest to least. Okay, and there is a typo here, guys. This should be descending. Okay, so I can write that in there. That way we know. Okay, so let's go ahead and look at the numbers in the table. The first thing I notice and the first thing that you should notice is that these are all in different forms. Okay, and again, we talked about yesterday, before we can compare, they have to be in the same form. So this is where your calculator comes in handy, and you can convert them all to decimals so we can compare them. So get your calculator out. Okay, if you want to pause the video and work this on your own, feel free to, and then come back and see if you got it correct, or you can just simply watch me work through these examples, and there will be opportunities after this for you to work on your own. So first things first, we want to change the numbers that are not decimals into decimal form. So I'm going to start with wanna, and I'm going to change the square root of 28 to a decimal, and I'm just going to approximate this to 5 3/10. Leanne, 23 over 4, or 23/4. Again, from 6th grade, we did that fractions to decimals. We talked about changing a fraction to a decimal. We just take the numerator and divide it by the denominator, and that's essentially how you can put it in your calculator. So I'm going to take the numerator 23, divide it by the denominator 4, and I'm going to get 5 75/100. Rain, we don't have to worry about. That's already in decimal form. And Jackson, 5 1/2 is one of those benchmark fractions that you should already know, which is 5 5/10. Okay, now that they're all in decimal form, I'm going to get rid of my calculator, and I'm going to go back to make sure that I'm going to put them in the correct order. And again, we want to go from greatest to least because they use that word descending. So here I can look at these and I can automatically see that 5 75/100 is the largest. So Leanne is going to be first in my order. Okay, and so I can mark through that. Okay, we have Wanna, Rain, and Jackson. okay? And if I look here, I have 5 and 3/10, 5 and 5/10 repeating, and 5 and 5/10. And out of these three, I can still see, or I can see that 5 and 3/10 is the smaller of the three. So that one's going to be at the end. So Juana is going to go down here. Okay, so I can get rid of this. And so now I'm just looking at Rain and Jackson. And they appear to have the same numbers. So what you could do, and is what we talked about yesterday, is lining up those decimals. So I'm going to take Rain, and this 5 repeating, remember guys, this little line repeating, means that this 5 just keeps going and going and going. Okay, I'm going to take Jackson, 5.5, and his number is not repeating, it doesn't keep going, so then I can just fill in a 0 here to compare. Now, if I'm looking at these, 5 and 5/10 repeating is larger than just 5 and 5/10. So Rain is going to be the second largest, and Jackson is going to be here. So now I arrange them from greatest to least. Okay, next example. Two numbers are shown on the number line. Which value is not located between these two numbers on the number line? So if it's telling us not located between the numbers, I'm going to just put an X here because I don't want it to be there between the numbers, okay? But I do want to look at these answers to determine, okay, well, which one actually does fall between there? And also, look at your number line, guys. The square root of 9/3, I'm not sure what number that is. I don't have any information about that. So again, let's look at our number, guys. This square root of 9/3, I don't really know what number that is. So I'm going to get my calculator out, okay? And I'm going to make them into a form that I do know. So taking that square root of 9, okay, and dividing by 3, and I get 1. So now I know that at least I want a number that is less than 1, okay? And let's look at what 2 pi is. 2 times pi, I get 6 and 28/100ths. So then I need a number that is less than 1, but greater than 6 and 28/100ths. So now look at my answer choices. I have no clue, guys, where those would be. So again, you need to use that calculator to change them to a decimal so that way you can easily see and find your answer choice. So option A, this pi, again, put it in your calculator, guys. 3 and 1, 1, 4, 1, 5, and I can keep going. Okay. And again, is that less than 1? Nope. So, and is it greater than 6? No. So this would fall between this red area here. So I know that that's not my answer. The square root of 9, again, you should know that. That's a perfect square. That one's going to be 3. And again, I'm looking for a number less than 1 or greater than 6 and 28/100ths. 3 falls between this red X, and again, that's not what I want. So option B is out. Option C, pi divided by 9. So I'm going to put that in my calculator. Pi divided by 9. I get 34/100ths. I'm going to ask myself, is that less than 1? Yes. Okay, so this could be a possibility. But again, I want to go ahead and work through option D just to make sure. So I'm going to take my pi and I'm going to square it. And then I'm going to divide it by 9. And I get 1 and 9/100ths. But again, this is greater than 1. This would fall in this red area. So that's not my option. So again, we were correct in thinking that C, pi over 9, is my answer. All right, move this calculator out of the way. Next and last example. 3 groups of students used different methods to estimate the diagonal length of a patio in feet. Their results were, and so it's given us the results here, 4 and the square root of 13 feet, 14 14 and 2/5 feet, and 14 and 33 hundredths feet. But the question wants to know which list shows the diagonal lengths in order from greatest to least. Okay, so this problem was nice enough to use those terms that we are familiar with, greatest to least. So again, I want to start with the largest number and I want to end with the smallest number. And so first things first, we need to make sure that all of these are in the same format. So once again, we're going to use our calculator and I'm going to change them all to decimals. So 4 and the square root of 13, and I get 14 and 42 hundredths approximately, because again, it's not an exact number because that decimal keeps going. 14 and 2/5. So again, we have our whole number already with this mixed number. We're just trying to figure out the decimal part. So I'm going to take that fraction, change it to a decimal with division, 2 divided by 5, 4/10. Okay, and lastly, this one, 14 and 33 hundredths, is already in decimal form. And I already went ahead and lined my decimals up, but I am going to fill in this 0 here to make it easier. So I've converted all my numbers. I'm going to get rid of my calculator, and I just need to put them in order from greatest to least. Make sure, guys, you're always going back to your word problem to make sure that you are putting it in the correct order. So I want to start with the largest and I want to end with the smallest. So here I'm going to just go place by value by place value. The tens place, 1, 1, 1. They're all the same there. So I move to the next place value, the ones place, 4, 4, and 4. Still the same, so I can't really tell the difference. I'm going to go to the next place value, 4, 4, and 3. Now out of these, I know that 3 is smaller than 4, so I know that I'm going to end with 14 and 33 hundredths. Okay, I just need to figure out these two here. But if you look at your answer choices, it only gives us one option with this at the end. Okay, but I do want to make sure, so I'm just going to finish ordering them before I actually choose my answer. That's just good test taking strategies. So this one is out of the picture. I put that in my list. The second thing I need to do is go to the next place value, and I have 2 and 0. Well, I know that 2 is larger than 0, and so again, I want to go from greatest to least. So I need to start with that largest number, and that happens to be 4 and the square root of 13, which leaves me to just have 14 and 2/5. And let's just make sure that this option D that we thought in the first place is the same as what we have, and it is. So then D is our answer. Okay, so go ahead and work through the next 3 examples in this Nearpod, and hope to catch you at one of my office hours, again at 9:30 or 2. And if not, have a great day.